Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the power spectral density, and this is the previous examination question. The example is a random process x of t has autocorrelation function Rxx of tau is equal 1 minus mod tau for tau is equal to minus 1 to plus 1 and Rxx of tau is equal to 0 otherwise. Determine the power spectral density and draw its spectrum. Coming to the solution, given that Rxx of tau is equal 1 minus mod tau for tau is equal to minus 1 to plus 1 and Rxx of tau is equal to 0 otherwise. So we know that the power spectral density of the autocorrelation function is Sxx of omega is equal integral minus infinity to infinity Rxx of tau into e power minus j omega tau d tau. Applying the given autocorrelation function here, so therefore Sxx of omega is equal integral minus 1 to 1 minus mod tau into e power minus j omega tau d tau. Mod tau means plus or minus, so positive values and negative values, and tau less than 0 mod tau is equal to minus tau and tau greater than 0 mod tau is equal to plus tau, and applying that condition into here we get Sxx of omega is equal. So minus 1 to 0. Minus 1 to 0 means tau less than 0. Tau less than 0 mod tau is equal to minus tau. So 1 minus of minus tau is 1 plus tau into e power minus j omega tau d tau plus 0 to 1. Integral 0 to 1 means tau greater than 0. Tau greater than 0 means for tau greater than 0 mod tau is equal to tau. So that is 1 minus tau into e power minus j omega tau d tau. So now we are multiplying e power minus j omega tau within the bracket term and applying the integration into each term. We have integral minus infinity to minus 1 to 0 1 e power minus j omega tau d tau plus integral minus 1 to 0 tau e power minus j omega tau d tau plus integral 0 to 1 1 e power minus j omega tau d tau minus integral 0 to 1 tau e power minus j omega tau d tau. And the first term integration, okay. Uh, and the first term integration is e power minus integration is with respect to tau here. The first term integration is e power minus j omega tau by minus j omega over minus 1 to 0, and this third term integration is e power minus j omega tau by minus j omega over 0 to 1, and second term and fourth term using udv concept. So udv is equal uv minus integral v du. Now here tau is considered as a u, e power minus j omega tau is considered as a dv. U is equal to tau, dv is equal to e power minus j omega tau d tau. So differentiating u with respect to tau, du is equal to du is equal to d tau, and integrating this consideration on both sides, v is equal e power minus j omega tau by minus j omega. Therefore from the above equation Sxx of omega is equal, the first term integration is e power minus j omega tau by minus j omega over minus 1 to 0 plus second term integration, second term applying udv concept. So udv is uv minus integral v du. So u is tau into v e power minus j omega tau by minus j omega over minus 1 to 0 minus integral minus 1 to 0 v. So v is e power minus j omega tau by minus j omega into du. Du is equal to plus, and third term integration is e power minus j omega tau by minus j omega over 0 to 1 minus fourth term integration using udv concept. U is tau, v is e power minus j omega tau by minus j omega over 0 to 1 minus. So now here fourth term before minus is there. When we multiplying minus within the bracket term, minus into minus plus. So directly I am writing plus here, minus into minus plus. Integral 0 to 1 v. V is e power minus j omega tau by minus j omega into d tau. So in the first term applying upper value of tau and lower value of tau, we have 1 minus e power minus 0 is 1 minus 1 minus e power j omega by minus j omega minus plus into minus minus. Now we will substitute upper value of tau into something 0, tau into something 0, and lower value of tau is e power minus j omega into minus 1 e power j omega. So uh, minus, okay, when you substitute the lower value of tau, the term is minus. Now here before minus is there, plus into minus minus, minus into minus plus e power minus 0, e power 0. Okay, okay. So now here substitute, and first term is 0, and the second term is second term is minus 1 into minus 1 into e power minus e power j omega by minus j omega. Okay, minus tau. So okay, plus into minus minus e power j omega by j omega plus, and here minus into minus plus 1 by j omega. So integrating e power minus j omega to d tau, e power minus j omega tau by minus j omega over minus 1 to 0, plus here substitute upper value of tau, e power minus j omega, minus substitute lower value of tau, e power minus 0 is 1 by minus j omega, plus here substitute upper value of tau, 1 into e power minus j omega by minus j omega, minus substitute lower value of tau, 0 into something 0. So minus into minus plus, so plus e power minus j omega by j omega. So plus into minus minus 1 by j omega, integral e power minus j omega tau integration is e power minus j omega tau by minus j omega. So in this term and in this term, substitute upper value of tau and lower values of tau. So that is equal, the RHS term is, and simplifying this RHS term, now here minus 1 by j omega plus 1 by j omega is the cancel, and e power j omega by j omega minus e power j omega by j omega is the cancel, and here also minus e power minus j omega by j omega plus e power minus j omega by j omega is the cancel, and the remaining RHS term is minus 1 by j omega whole square plus e power j omega by j omega whole square plus e power minus j omega by j omega whole square minus 1 by j omega whole square. So minus 1 by j omega whole square minus 1 by j omega whole square is minus 2 by j omega whole square, and these two terms j omega whole square is the common. So e power j omega plus e power minus j omega by j omega whole square. Now take the LCM. So j omega whole square, j omega whole square is, so j omega whole square, j square value is minus 1 and j square value is minus 1. Now before minus is there, minus into minus plus, therefore the RHS term is e power j omega plus e power minus j omega is 2 cos omega minus 2 cos omega by omega square plus 2 by omega square. So which is equal, LCM is omega square, 2 minus 2 cos omega by omega square. The numerator term 2 is the common, 2 into 1 minus cos omega. So 1 minus cos omega in terms of this sign, 2 sin square of omega by 2 by omega square, before 2 is there. Therefore Sxx of omega is equal 4 sin square omega 2 by omega square. So this is the power spectral density of the given random process, given autocorrelation function.